Hello, this is Dead Hamster. Today we're going to do something a little different, a little bit more technical. I haven't done one of the more technical discussions on Mario Kart in a while, and today I have a very good reason to. The video you just saw before was the old processing versus the new processing. I've discussed in a lot of my recent live streams about a more optimized way to draw geometry that I've been able to work on recently. It's nothing new, nothing wildly creative, but it is something that I recently implemented to Overcart, and you can see the difference there. What that was a stress test of over 5,000 triangles and about 40 different materials, trying to push the Nintendo 64 well past its limits. Drawing with 4 players means that it's over 20,000 triangles actually. Quite a lot for the N64 to handle, and as you can see, it's not able to do so at full speed. But there is a noticeable difference between the old method of drawing the geometry and the new method, which is about 40% faster actually overall. Very excited about the improvements, and I want to take a little time to explain in detail how I figured out, kind of came to the idea, and the way that it works in the background, so to speak. The very short and sweet, simple version of it is that there is less texture loading. I've offset the textures into their own display lists and organized the display list by texture, and because of that, I'm no longer loading a texture for each object. That's the short and sweet version, but to understand why that actually matters and what that means, I'm going to have to go into a bit of an explanation with everything, so we're going to go ahead and take a step into that now. So looking here, this would be a standard scene for Mario Kart. This is the starting of Luigi Raceway, and there's a lot going on here. A lot of different pieces of geometry are being drawn in the scene. Textures have to be loaded to draw those. When you're talking about drawing geometry at the most basic level, there's basically 3 things that go on. You're loading textures, you're loading verts, and then you're drawing triangles using those textures and those verts. The verts will have the XYZ coordinates and the tiling, the UV tiles of the bitmaps. The faces have to have the connecting verts and what orders, and then the textures assigned to those faces are represented in a 3D environment. Now, of course, the camera has to apply a perspective view and do all sorts of math in order to interpret that, but at the most basic level, drawing geometry is comprised of those 3 steps. You're loading textures, loading verts, and then drawing triangles. With the optimizing, a lot of this came from the N64 hardware itself. Now, this doesn't change anything on emulator. It'll run just the same as it always has, but on the actual console and hardware is where the differences are. Now, I was reading a lot of specification documents and tech sheets about the N64 and the hardware architecture and the way the different chips interacted, and this is when I kind of started to stumble upon this idea, and doing a bit of searching after I came up with the general idea of moving it over. I found a post a few years ago by a person named David on a website for modding for Mario 64, discussing the same kind of concept, and that's what really solidified and cemented the idea that, yeah, this was something I should look into, this would probably work, and as you can see earlier with that increase, it was definitely effective. So looking at the N64 hardware, we have the actual motherboard here with all the plastic around it removed. On the left side, you have the CPU, which is running the main instructions. In dead center is the GPU. Now, this is the graphics processing unit. It's actually split into 2 separate parts. There's the RSP, which is the reality signal processor. That's sending the actual graphics data to the video out to export to the TV and to display on screen. Then there's also the reality display processor. Yes, the display processor. I wasn't sure which one I said first. That one is actually doing the calculations and processing of the geometry and rendering and things of that nature. Both of them, as well as the CPU, access a shared bank of RAM. Now, this is RDRAM. That's important because at that time, and I don't know if it's still the case, RDRAM has very high latency. I'm not a very good hardware guy. I'm not familiar with how these things worked. As I said, I was just recently reading specs and docs, but I do know that everything I read said that RDRAM had a very high latency, and I know that, of course, is bad. Attached at the end is a terminator strip, the expansion RAM. It does need to be terminated, so if you don't put that jumper pack in, the system won't start. And then at the very top, we have the cartridge port, where the main data for the game is stored before being loaded into RAM to be processed by the CPU and the GPU. Now, on that note, something very important is that the controller for RAM is the GPU. The graphics processing unit is actually in control of doing DMAs, direct memory access, to the cartridge to load info into the RAM chips. So the CPU is incapable of loading data itself. It has to do so through the graphics processing unit. That also means that while the graphics processing unit is running, it's not able to utilize the CPU to load data into RAM. It has to stop what it's doing in order to load texture data and into memory in order to access it. That is important because the texture cache, as it's referred to as the N64, is only 2 kilobytes in size. That's very small. You can basically only load one texture at a time. Because of the latency, the issue with DMAs not being able to be processed by both chips, and the small cache of the textures, you end up with a lot of slowdown from having to load successive textures into memory in order to draw geometry. This is kind of required in a lot of scenarios because you're going to have to, of course, load the textures for the objects, and you don't necessarily know what's going to be there before you're loading it, so it's difficult to offset or organize these things. We're going to kind of take a look now at I'm going to take a look at what the N64 was doing in the original devs, the Mario Kart devs were doing. So if I were to look at this is Donkey Kong Parkway. So this is something I've covered in a previous video as well in bigger detail. I'm just going to touch on it briefly here. We're looking at a start of display list command. This is the RDP, the reality display processor. It's a tile sync. I don't know the specifics, but it's a command to do some type of syncing with the RDP. This here is setting texture tile parameters. This command is, well, let me double check that. This is setting the texture parameters. This is setting the tile size. This is loading a texture from segment 5 at offset 8000. Again, we're doing another RDP sync. We're doing some type of alignment again with the texture parameters. This is a RDP load sync. So the other one was a tile sync. This is doing a load sync. F3 is loading block texture data. Not sure the specifics of that. So this whole strip here is to load the texture and set up the parameters and the tiling and the size of the texture itself, the dimensions, the width and height. Now finally here with 04, we're loading verts from segment 4 at offset 2200. We're drawing two triangles, and back to loading textures from segment 5 at offset 9000. Doing the tile sync, doing texture size parameters, RDP, what's this one? This is the load sync, texture block load again, and okay, cool. Well, now we're back to loading verts. So load verts from segment 4, draw two triangles, and back to loading textures again. And you can see they do this again and again and again in this particular piece of geometry from DK Parkway. It's the trees on the side of the level. They used 4 textures across, and because to add some variation and to make it look better. But the way that the object was processed is, okay, so we have these faces use this texture, these faces use this one, these use this one, these use this one. Here's the chunk of code for drawing this object, and we're going to put that here. And to explain what I mean by that, I need to take a step further back again and take a look at what the levels look like in a 3D editor when you break them apart and you're not looking at them. So there's 2 pieces of geometry drawn every frame. There's a surface map, which is very simple and is used, you don't actually see it, it's only used for calculating collision with the player. Then there's the actual geometry, and this is much more complex. not everything is drawn every frame. In order to optimize and make sure that the game isn't overdrawing, they implement view culling. The way Mario Kart's view culling works, it's not dynamic. You can see here that the section, the surface map, I have color coded. Each surface area is assigned a section ID. So all the objects here that make up this surface are assigned an ID value that they share. When I'm driving on this surface, the game has a list of objects that it decides to draw that were pre-processed and predetermined by the game developers based if I'm looking north, east, south, or west. If I was looking at that list here for Donkey Kong Parkway, you can see I have a jump here for north, then east, south, then west, and then it just repeats. And this goes on and on. The game will jump to this table, determine which section you're in, which direction you're facing. It will find this jump, this display list jump to other code, and it will go to that jump and process all the objects there and draw them to the scene. And that's how it determines which of these giant list of objects to draw based on where you are and where you're looking. So to kind of give an example of how that might look, again, we have north, east, south, and west for each section. I've color-coded again. These all, if this one jump right here, section 1 north, will have a list of objects. This is an object, this is an object, this is an object. These will all be another jump. So it'll be a jump to a table of jumps. And each of these jumps will point to object code, like we looked at before for drawing actual geometry. So we have to get to the total list of objects for this section and this view, and then each one of those objects will be the code itself to draw it. Now when we've made our way down to that level, we're going to have something like this. I've color-coded again. Green is going to be the commands to load a texture. Blue will be commands to load verts, and yellow will be commands to draw triangles. Now in a healthy display list for an object, this is what it should look like. You should have a bunch of commands in the beginning, and it does take a bunch of commands to load textures. You should be loading verts and drawing several triangles using those verts before you have to load verts again. Depending on the microcode you use, you'll have between 16 to 64 verts in the cache. For Mario Kart, it's 32. So again, for a healthy display list, it'll look something like this. For the Donkey Kong Parkway display lists, it looks more like this. You have texture loading, vert loading, a small amount of geometry getting drawn, and then texture loading again. Now the big thing that we're looking for is drawing triangles. We want to see triangles on the screen because to the player, that's the end game. We don't care about how much processing time is put into loading the background data, the verts and the textures, because that's not drawing geometry to the screen, which is what we're looking to do in the end. When you break it out into each object and you're actually looking at, okay, we need to draw this object and that object in this whole list, you end up spending almost your entire processing time drawing textures, loading textures rather, from memory. And then you can see a good amount of time as well in the blue spent loading vert data. This isn't good. The light blue, by the way, is a terminator. That's ending the list, jumping back. Not important. The dark blue, however, is loading vert data. You can see the yellow, which is what we care about. There's not even that much of it in this scenario. We're really doing a small amount of processing time drawing triangles. Even in our healthy display list, you can see a huge amount of time spent loading texture data. This is a huge waste of processing time, and this is why the games needed to have a tempo modifier that would increase the frame rate. They just could not, unfortunately, keep up with the geometry they were trying to draw on screen in multiplayer mode, in 3-player and 4-player. So to change this, what I've done differently, while I'm pre-processing my list of objects, I organize them by texture. I determine if that object is matching this texture, if it needs to be drawn in this section and in this view, and if it does, and only if the texture hasn't been loaded, I load a texture. Then I draw the object. If the texture has already been loaded, because we do them in texture order and we go over the list multiple times, I just draw the object itself. In order to do that, I've separated the code out. Each texture has its own display list to load, and each model is, or each object code in the display list is only vert loading and triangle drawing. So what that looks like is something like this. First, I would say, okay, I'm drawing a new object, so I need to load texture data, and the whole display list is loading texture data. Now it looks like a lot, but really it's not this big. I've just made them the same size. It's the same number of commands it normally would be. Probably 4 or 5, whatever it is, maybe 8 or 9 commands in order to load a texture. From that point, it jumps back to the other display list, and the next one just draws objects. The next one just draws objects, loading verts as well when needed. Loading verts when needed and drawing objects, and then finally, after I've drawn all the objects that use this texture, I move on to the next one. I load another texture block, and then I'm drawing objects again. Every object that uses that texture gets drawn, then I load the next texture again and draw all the objects that require them. This is what led to that drastic increase in performance. This is why the game runs 40% faster now with my custom levels. Couple things to note. This is really easy for me, relatively, because of the unique way that Mario Kart is set up with the sections and views. Other games might be able to do something similar with this, like GoldenEye, but any game like Banjo, for example, that uses a dynamic camera will have a lot of difficulty with doing something like this and organizing the objects, because you need to, again, ensure that an object's textures have been loaded before this object is being drawn, and that no other texture has been loaded in the meantime. There's only enough room in the cache for one texture, and it's not even really a cache. I keep using that word with quotes. I don't know the specifics, but I know it's not a true texture cache. But again, it is a one texture wide chunk of memory. So you have to be sure, again, that you're loading it before you draw these objects, and that's difficult to do in any game that would have dynamic view culling. Thankfully, Mario Kart has this static system that's pre-processed, and with a little bit of care and extra time, not extra time at all, just an extra couple routines, we're able to really improve the performance on these levels, which will really help with making these work better in multiplayer. Something else that's interesting, again, I've showcased how bad these original levels are relatively compared to what they could have been. This is something that's feasible to backport to a lot of these levels, but the work involved is enormous, and a lot of it is hands-on work. As you can see, a lot of these jump between textures and jump between objects inside the display lists, so it's not really something you can write an automated process for and click a button and let it do itself. It would really take a lot of work and organizing, so while it's something I'm interested in looking into, the feasibility of it is certainly questionable. Additionally, I'm sure I've made a lot of mistakes as to the terminology and my descriptions on the hardware and the way that these things work. I am not an expert. I'm just figuring these things out, looking these things up again, as I was saying recently, in some other documents and things, and came across these ideas. So please feel free to comment and correct me and tell me where I'm wrong. Maybe I'd be able to prove this even further based on your comments and corrections. As always, really appreciate the support and the interest from the community. I think this is going to help. I've been talking about this for a while. Make these levels run a lot better on console, and I'm excited for that. Excited to see what other things come out in the future as we continue to work on this. So as always, if you want to kept up to date on Mario Kart modding news, go ahead and hit the subscribe button below and join the Discord server. I'll make sure to have a link in the description. As always, again, appreciate you guys. Until next time, take care.